All right, 6.1. We're supposed to find the arc length and the area of a sector's formulas. It says the length of an arc, S, is this. Now I gave it to you as the length of an arc in this my notation, which was the measure of the angle in radians times. If you measure the angle in radians, then that tells you how many radiuses fit out here. So you just multiply this amount of radians times the radius. So they want you to say the theta times r, but theta has to be measured in radians and r is the radius. And the area of a sector, this is similar to a triangle, and the formula is similar to the triangle. It's 1/2 base, which would be the arc length, which we just did, theta, measure of the angle in radians. That's how I did it. I did 1/2 measure of the angle in radians times the radius, that would be the base, 1/2 base, times the height, which is also a radius. So it's times the radius squared. Now, 66 says turn 0.75 radians into degrees in decimal. Well, to do that, we need to use either multiply by 180 degrees is pi radians, or pi radians is 180 degrees, but we're trying to get radians to cancel, so we're going to take 0.75 times 180 degrees divided by pi radians. And so our answer in decimal form is 42.97183463. But anyway, now if I want to change it to degrees, decimals, whatever, degrees, minutes, seconds, it's 42 degrees. So then I take this decimal value, subtract the 42, so I get just the decimal part, and multiply that, because this says, basically it says 97% of the minutes, and each minute is worth 60, so I'm going to take it times, each degree is worth 60 minutes, so I multiply by 60, and I get 58 minutes, but 0.310, and so that's going to make our seconds, so I get rid of the 58 minutes by subtracting the 58, and then multiplying by 60, so that this fraction of a minute turns into seconds, because there's 60 seconds in a minute, and that turns out to be 18.6046 18 minutes, and it has the decimal part 60 whatever, but that would be close enough. Okay, and then we're supposed to find the missing piece, and it says the arc length is 3 miles and the radius is 5, and it says what's the angle. As I said, the book says the arc length is equal to the measure of the angle in radians times the radius. So we have the radius and we have the arc length, so we have 3 equals the measure of the angle in radians times a radius of 5 miles. So if I divide by 5, and this is 3 miles, we get, divide both sides by 5 miles, and the miles cancel, and I get an angle in radians of 3/5 radians. And then finally it says find the arc length and the area if the angle is pi over 3 and the radius is 2. So the arc length is simply pi over 3, the measure of the angle in radians, times the radius, so that comes out to be 2 pi over 3 feet, because the radius was in feet. And the area of the sector is 1/2 times the measure of the angle in radians, which was pi over 3, times the radius squared, which would be 2 times 2 feet squared. And area is in square feet, so that's good. So one of these twos cancels the half, and the other one makes it 2 pi over 3 feet squared. Same size, but just happens to be the sector that has the same length of arc number as the number of squares in it. And that's the ones for 6-1.